Good evening, and thank you for being here. You guys are warriors. I wouldn't come even if I have to listen to myself at 7 p.m. So thank you for coming. We really appreciate it, and we have something very exciting for you. So this session is about how two of our customers have migrated their workloads from running on-prem to Amazon EMR, and the other one from running Hadoop on EC2 to EMR. They're two very different use cases. So we'll talk a little bit about migration from on-prem or on EC2 to Amazon EMR. The focus of the session is going to be a lot more on the why instead of the how. We will cover the how as well. But these two customers are Airbnb and Guardian. You kind of heard about both of them in today's keynote as well. And I kind of looked at these two customers, and they're very interesting use cases. One of them, Airbnb, has migrated migrated to EMR, and they were already on the cloud. They were using Hadoop on the cloud on EC2 machines, so they have a different story to tell. And the other one, which is Guardian, they were actually running Hadoop on-prem, and they migrated to EMR as a part of their migration, their all-in story onto the cloud. So they're very, very different stories to tell. And we believe you'll take something back from both of these stories and both of the experiences. So we'll talk a little bit about I'll set the context around when we look at customers and when they migrate from on-prem or on EC2 to EMR, what are the main reasons customers choose this migration? And then we will look deeper into these stories. So the primary reason, I think, is how Hadoop deployments or Hadoop or Spark deployments today are very tightly coupled. The storage and compute for these deployments are very tightly coupled. So for example, in an on-premise world, when you buy a server, you also buy storage along with it. And when your storage goes exponentially, your servers also grow exponentially, right? So it's because your storage and servers are very tightly coupled together. So as you get more data, and maybe with HDFS you have 3x replication, your storage starts to keep growing. So we often hear of 100 petabyte Hadoop clusters or 10 petabyte Hadoop clusters. But when you go and talk to people who are running those clusters and you ask them, what kind of jobs are you really running? They would say, oh, the 100 petabyte is there because we're using HDFS. All the data is co-located on one cluster. But really, the jobs that run process 1, 2, or months of data. The size of the cluster is really because of the amount of storage. And you have to keep buying compute because the storage keeps growing. Compute requirements generally vary, right? So for example, what we see mostly in on-prem Hadoop deployments is that you see a peak at the time when all environments or all lines of businesses are running their jobs, or maybe 12 in the night, all jobs start their ETL process, and 9 in the morning, there's a lot of ad hoc job. And at that point of time, you run out of capacity, or you're running at peak. But on the other times, you're basically running low on capacity. So underutilization or scarce resources. So you see a very common pattern when you look at utilization graphs from on-prem clusters. So you would see something like this, which is a weekly peak. You see a massive peak when you have to reprocess the data, and you see a steady state most of the time. And this creates a lot of opportunities. Your compute essentially is completely underutilized. You also see contention for the same kind of resources, and especially because this Hadoop and Spark and Presto, and there's lots of different kinds of applications customers are running on a central Hadoop cluster. The reason you are multi-tenanting all of these on a single cluster is because the data is on that particular cluster. So you have jobs that are compute bound, you have jobs that are memory bound, you have jobs from different departments. And if you do also have requirements where you have different departments wanting to use different versions of the same software, and that could cause a lot of contention. If you do separate them out, it tends to create data silos. So you now have to either separate out the data, or you create or recreate the data between each of these clusters. Tends to create data silos, which you really don't want in a longer period of time. Replication also adds cost to HDFS replication is also cost. And this cost still doesn't give you high availability because all of these are actually sitting in a single data center. Now let's look at a little bit from an application point of view. When you look at an application point of view, we see some common patterns emerge. For example, there is large-scale transformation going on, and that can be based on MapReduce, Hive, Pig, Spark, so on and so forth. There's interactive queries going on, specifically Impala, Spark SQL, or Presto. There's some machine learning going on. There's some ad hoc usage of interactive notebooks for data science workloads, and there may be some NoSQL-based workloads. If you look at all of these workloads, they have very different characteristics, but they are all multi-tenanted on the same resource because your data is in the same resource. And your clusters are so big because your storage and compute are essentially coupled together. Here's what when we look at this, this is a real customer example where I asked them to build a swim lane of all the jobs that they run daily. And these are essentially some jobs. So you'll see that there are some large ETL jobs that start at the midnight. There are some jobs that keep running every hour. There are some jobs that run occasionally, and there are some jobs that are ad hoc. So if you look at the first circle, that's the place where your cluster is completely overutilized. And if you look at the second circle, you would see that the cluster is completely underutilized. So what EMR tends to do, it allows you to decouple storage and compute. And where we use our storage as S3, because you want different requirements from each one of them. What we want to do is decouple your storage and compute so that you can independently scale them. And there are several reasons now why customers would want to do something like that. So when you decouple storage and compute, the storage of our choice that we use is S3. You get 11 nines of durability, low cost, lifecycle policies, and now with the announcement that you saw, machine learning-based lifecycle policies, versioning, and you have a layer on top of EMR that allows you to read and write directly to S3, which we call EMRFS. So what are the benefits of decoupling storage and compute? Now, if you think about it, a 10-node cluster running for 10 hours costs you exactly the same as a 100-node cluster running for 1 hour. So the benefit is that with EMR, if your data is sitting on S3, you can spin up a Spark cluster, you can process your data, and then you can switch off your cluster. So if you look at this diagram that we started with, a lot of jobs in here start and stop at the same time. If I had data that is sitting in S3, essentially the blue and the red lines can be individual clusters, job scope clusters. That means those clusters only run those jobs. They can be spun up, they can process the data, and you can just spin down the cluster. So what we see customers do a lot is they take their architecture, they work on the architecture from a job point of view, and then decouple all of these, or deconstruct all of these into individual purpose-scoped clusters. Some of the jobs which run for 4 to 6 to every hour, that basically becomes your transient clusters. That means you can spin up a cluster and spin them down. The jobs that run on a persistent basis become your persistent cluster. That means you spin up a cluster and you don't have to shut it down. Also, because your data is sitting on S3, you can also auto-scale your clusters and save cost. That means you can scale up your cluster. For example, a very good use case of a persistent cluster is when you have lots of users using maybe a Jupyter notebook with it. So EMR provides like a native Jupyter interface. So you can have multi-tenanted, a single cluster multi-tenanted by multiple users all running Jupyter interfaces or Jupyter notebook. And when they all submit jobs, the cluster can scale up and scale down based upon the capacity requirements that each of these jobs might have. The benefit number 3 is you can logically separate these jobs. For example, if you remember the swim lane that was there, I can essentially upgrade each of these jobs to a different version because I'm running them all on different clusters. Also, there is a low blast radius of failure. For example, if one of these jobs fail, it is not causing all of my jobs to fail on top of S3. Also, you don't have to manage complex queues in this segment because you're building purpose-scoped clusters. And you have disaster recovery built in because S3 allows you to, S3 replicates your data across multiple availability zones. So if in fact you have one availability zone go down, you can essentially spin up the cluster in a completely different availability zone. You don't need disaster recovery. You can also build regional disaster recovery by cross-replicating cross-replicating your data into another storage. So these are some of the advantages of decoupling your storage and compute. And I think that is the most important reason that customers migrate from their EC2 environments or on EMR environments, on on-prem environments to EMR. To tell you the story, let me first invite Jian Chen, who's a software engineer at Airbnb, to talk about how Airbnb is migrating from running Hadoop on EC2 to Amazon EMR and S3. Jian. Is he audible?
Hello. Nice. Yeah. Hi, everyone. I'm Jian. I'm a software engineer at Airbnb. Unfortunately, Guang couldn't make it today because of a scheduling conflict. And we're going to share you our story of migrating from EC2 to EMR and S3. I'll briefly talk about our existing data infrastructure at Airbnb and the kind of challenge we are facing this day, and why choosing EMR and S3 is going to be good for us down the road. And I'll conclude with a migration lesson we have learned so far. Airbnb is a data-driven company. We provide personalized recommendations and better search results for our guests. And as a host, you can use a smart pricing feature to increase your overall booking rate and your total revenue. Internally, the data platform team powers tons of company metrics and supports the generation of important financial reports. And there are a lot more use cases that I can talk about. This is a snapshot of what data infrastructure looks like in 2014. We have two major incoming data sources, event logs and MySQL dumps. Event logs get generated from web servers and different kind of online services. These events get published to Kafka and batch ingested into our data warehouse. And at the bottom, you see the MySQL dumps. Those are basically daily snapshot of MySQL's databases, and those get ingested into the data warehouse as well. And we have two main data warehouse clusters, Gold and Silver. They're sitting in different AZs. We use Re-Air to basically another in-house project to copy the critical data from Gold to Silver to provide isolation and also disaster recovery. Users, they can schedule their Hive or Spark job using Airflow on top of a platform by just simply pointing the configuration to either Gold or Silver. If the job is high SLA, they can just run it on Gold. If it's lower priority, they can choose as Silver. This model served us pretty well for 1 year. And then we started to support more use cases, adding HBase and Presto into the picture. And we also created more compute-only cluster to serve streaming use cases. We are seeing a trend within the company that more teams are migrating their Hive jobs into Spark jobs simply for better performance and easier testability. And they also have more streaming use cases. I think all the streaming use cases at Airbnb are run using Flink or via Airflow, Airstream. Airstream, which is another in-house streaming framework on top of Spark streaming. And around this time, I think we started seeing a scalability issue with HDFS. That's why we began archiving code data onto S3 periodically. And that's the trending we're seeing, more Spark workload and streaming workloads, as we mentioned earlier. Yeah. So Airbnb is growing very fast. Our business is growing, our employees double year over year. So there's a number of jobs running on clusters. And growing fast is great, but some issues started to bite us. Our compute and storage are tightly coupled. As you can see from the graph, the top one is the compute usage throughout the day or time. You can see it fluctuates, versus the bottom one, the storage, is pretty flat, around 40%. At a peak, different teams are basically competing resource. And people will come to us and complaining, my job's not getting run, it's in pending state, or my job getting preempted for some high SLA jobs. But at another time, all the compute resources are wasted, it's not being used. Silver is the bigger cluster. Right now, it has more than 1,000 D2 AX large instances. And we have seen a couple times where Yarn does not schedule jobs, even though there's still available resource in the cluster. We still haven't figured out exactly what the root cause is, but failing over Yarn Resource Manager resolved the problem, basically. But on the other hand, HDFS, we reached 150 million plus data blocks, and that gives us serious problem. Is the long GC basically killed the name node and started having frequent failover, and the failover, and also when we try to restart a cluster, it takes a long time. We consider all these as major outages on our data platform. That's not good. And this is another picture showing you the lack of elasticity, wasting resources versus the contention at peak. Also, we're also running on some pretty old Hadoop software, 2.5 and also Hive 0.13. There are a lot of legacy jobs relying on these set of software settings. That's why it's harder for us to just do a simply upgrade a whole cluster with thousands of nodes on it. Since we provision the cluster for peak load, the capital expense is pretty high. And if you maintain a cluster on EC2 before, you know the operational overhead is quite high as well to add and removing instance. To do it gracefully, at least, is very hard. And it's very hard for us to allocate the cost across the entire organization in this multi-kinetic cluster setting. So why choosing Amazon S3 and EMR? As Abhishek kept mentioning earlier, is to decouple compute and storage. We like the idea of having S3 as the data lake and launching stateless compute infrastructure using EMR. So that, we believe, will reduce our operational overhead quite a bit. It's going to be easier for us to rotate, scale in, and scale out the cluster for different teams. And if we create different EMR cluster for each business unit, it's easier for us to attribute the cost and isolate compute resources for different teams. And they can even run their own customized software if they want to. They don't have to stuck with Hadoop 2.15 or Hive 0.13. So that sounds great. How do we get there? So today, we basically restrict the user to only write to HDFS, and as soon as the write is finished, we basically upload those data to S3. Right now, the goal is to cut off the read path for HDFS. And then we selected some non-critical jobs as a pilot use case on EMR. And these jobs running on some pretty static, long-running cluster on EMR. We try to mimic the same kind of setting on our existing structure where you have a gateway launching a job to a group of machines in a cluster setting. We try to mimic the behavior using the same software version and anything, try to reduce the problem we face, and then tune the system from that point on. So we have 4 long-running production cluster running, and they all have auto-scaling enabled. And those jobs seem to run 3 times faster than before, so that's pretty good news. Our next step is to migrate all the Hive application without impacting the user too much. The goal is, the ideal situation is users of those, owner of those jobs shouldn't need to worry about where the job is running, whether it's EMR or within the existing cluster, should have a 0 effort on their end, which means there'll be a huge effort on our side. And then we're going to start introducing an EMR job server to manage long-running and transient cluster in the future. This is what 2019 looks like, or hopefully this is what 2019 will look like. You have an EMR job server in the front to manage all the staging or streaming and different kind of cluster launched by a different team. And storage is all backed by S3 at this point. So we have a clear separation of a compute and storage. What have we learned so far? Well, number one, get it working first. Our first EMR cluster have the exact same setting as our existing infrastructure. By exact setting, I mean there's a gateway, there's a set of gateway submitting job to set a machine within a clusters. But in this case, the compute, the yarn node manager is running inside EMR. The user is still writing to existing HDFS, but they don't need to worry about what's behind the scene at this point. We're still pointing to the same high meta store. And then we started the EMR cluster with simply just one type of machine. We don't want to introduce too many variables at this point. We can tune the machine for the application later, but just for try now purpose and migration purpose, just one type of R4 AX is good enough for us. And picking the representative use cases, as I mentioned earlier, even though we pick non-critical jobs, those jobs, the pattern of those jobs represents pretty much 80% of what the main usage on our cluster looks like. So the learning from migrating those jobs can apply to other teams, hopefully easily. And the rest of 20%, we will migrate them at a later time of the day. Default configuration may not work well. So we have to tune some config on Yarn for just to get the first version of EMR cluster running. And one of the example is we had to increase the memory for node managers on EMR just because it crashed quite frequently. And there are many more. And then lastly, but not least, autoscaling is awesome. We like the idea of having the cluster scale by itself without human intervention. I think that saves us a lot of operational overhead. I think that's it for me today. And we're Wang.
Thank you, Jin. Hello, everyone. Thanks for being here tonight. I'm Wang Chung. My name is easy to remember because I have the same name as that cheesy 80s song, Everybody Wang Chung Tonight. I'm sorry, I just had to get that out there every time I might present, just in case you were thinking about that. So now back to the program. I lead the data platform architecture team at Guardian. The team drives the data management strategy for the company and also manage the Guardian Data Lake, which serves as a source for reporting and analytics. Today, I'll be talking about a topic that some of you are probably thinking about or in the process of going through a very similar journey, which is migrating your Hadoop data lake and workload to AWS EMR. First, a little bit about Guardian, who we are. Early this morning at the keynote, our CIO, Dean Tebecchio, on stage, was talking about the many exciting things that was happening at Guardian. I'll be touching on some of those transformation changes. In a way, he really stole my thunder, but I think it's okay. The company is over 150 years old, so we've been around for quite some time. We have employees over 9,000, over 2,700 financial representatives, and more than 55 agencies. Some of you in the audience may be a Guardian policyholder, and I want to thank you for being a loyal customer because we're in the business of providing products in annuities, investment, life insurance, dental, employee benefits, disability, and just a history lesson. A mere 3 to 4 years ago, there was no concept of enterprise data in the organization. Each of the business operated in very silo fashions. They had their own databases, data marts, in some cases even data warehouses. There was no cross-pollination of data across the enterprise. It makes you wonder how we survived for over 150 years. But to our credit, we're very good at what we do, but our executive leadership team recognized that We cannot continue to operate this way, especially if we want to be around for the next 150 years. So in 2015 is when they made an investment not only in a big data program, but also in modernizing our technology stack, introducing concepts such as DevOps, Agile, moving us to the cloud, and most importantly, fostering a spirit of innovation. We bring our vendors in, conduct Shark Tank exercise, voting thumbs up, thumbs down on new ideas to enhance the business. We have employee engagement on innovation challenges. I've been very lucky enough to be part of the journey and from the very beginning, and that transformation has been awesome. It really positioned us to be not only one of the leading insurance company, but a leading digital insurer. So in 2015 is when we stood up a Hadoop environment and started building our data lake. The year after that, we initiate a AWS migration program to move over 200 plus applications to AWS. We were all in. No longer did we want to manage the data lake or the data center. Next year, which is last year, we migrated off of Hadoop on-prem and all our data to S3 and all our data processing into EMR. This year, we continue to follow the coattails of the EMR product team by releasing new capabilities, enhancements based on each GA releases. Next year is when we really want to move the needle on advanced analytics, which we're going to be focusing on RPA, AI, and ML. So why did we migrate to AWS EMR? First, you have to understand our on-prem Hadoop architecture. At the time, we were using Pivotal, which was a Hadoop distribution, and the SQL on Hadoop was Hawk. We had 3 clusters. One was the ETL operation cluster, which connected to major data sources and start bringing the data into the cluster and doing transformation and data processing. We also have a data science cluster, which serves as a sandbox environment for our data science team to run their predictive models. And lastly, a disaster recovery cluster. As you can see here, this architecture poses several challenges. One of those challenges is that storage and compute are tightly coupled, which means that storage is fixed and making us very difficult to scale up and at a very good speed. Because these are physical servers, it was prone to disk failures, which we had to triage and troubleshoot. I mentioned about the inability to scale. For example, when we stood up our data science cluster, it took 6 to 9 months from provisioning, procuring the hardware, to setting up in our data center. In today's environment, that is just unacceptable. As you can imagine, managing multiple clusters is very costly. There's also additional DR costs because we leverage a third-party product to do data replication across the cluster. Because these were physical servers that was long-running, we weren't taking advantage of the unused capacity during off-peak periods. We were very inefficient utilizing these servers. Because of the nature of managing your data center, it requires a team of operators with boots on the ground at the data center to manage the physical hardware. And for all this reason, we were slow to adapt to changing business needs. Just to give you some background about our migration strategy, not only did we want to move to AWS because it was a company-wide initiative, but also there was a financial incentive. We didn't want to go into 2018, of paying our Hadoop subscription license. In fact, the subscription ended at December 31st, 2017, so that was our drop-dead date to move all our data, all our workload to S3 and EMR. Part of the migration strategy, we wanted to achieve a major theme in each of the quarters. They are cloud assessment and POC, security certification, environment readiness, application development and regression testing, data migration, and cutover. The migration was a one-year effort. It was a marathon, but it really felt like a sprint. In Q1, we conducted a cloud assessment and POC on EMR. These are the categories, the acceptance criteria, which we judge EMR on and graded. We graded from a scale of low, medium, high confidence, high being the best. For functional capabilities, EMR needed to meet our data processing and analytical requirements. Infrastructure and software cost was medium, but hindsight being 2020, I would rate it as high because it was substantial cost saving as opposed to us managing at our own data center. Integrating Active Directory and Kerberos was not out of the box. It required a custom solution. This was our first time also using Amazon Linux. So it requires us to establish a new minimum baseline security image. EMR is somewhat very sensitive to domain names. Because of our domain architecture, it requires a custom DNS. The team was already familiar with managing Hadoop, our data lake, at our on-prem, but this was our first foray into using EMR and S3. For product installation, deployment automation, and DR setup was high, and we felt very confident in managing our no risk factor during the migration period. For security certification, and those of you who are thinking about moving to AWS, I highly recommend that you partner with your IT security team. Contrary to popular belief, they are your friend, and they are critical to your success. We partnered with them from the very beginning. We sat down with them with our AWS partner and even the EMR product team to go over their security requirements and make sure that the security controls were in place. I mentioned the first time for us using Amazon Linux, there were cases where we had to seek a security exception. The EMR GA version at the time of migration did not have Kerberos integrated. So we needed to get a security exception to not use Kerberos. Also, EMR did not address some of the CIS security benchmarks, the Center for Internet Security Standards. There's cases that you may have to, for software products that you're using today, you may really have to peel the onions, make sure they're deeply integrated with AWS. For example, the ETL ELT tool we're using is SyncSort. We're probably one of the first customer of theirs to use S3 encryption. Part of the migration, they needed to make a product enhancement in support of our migration. To their credit, we were probably more of an exception than a norm, and they provide a quick turnaround. We use the edge node to serve as the gateway between S3 and EMR. No one can access our cluster, not even our admins. So we wall off all access and shut off any SSH. Mentioned about using the use of a custom DNS. For data protection and controls, we use S3 encryption, SSL, HTTPS. For multi-region DR requirements, we really love the fact that S3 support cross-region data replication from east to west. And in case of a DR scenario, we use automation to quickly spin up our edge node and our cluster in the west region. In Q3, Terraform and Puppet was used for automation in spinning up the edge node and cluster. Bitbucket Jenkins is part of our continuous integration, continuous deployment pipeline. We had to refactor and test over 300 plus workloads. Places where we touched code were SyncSort, PigScript, Python, R, Shell script. If you have to migrate, I highly recommend developing a very detailed code migration plan because we had to accommodate projects that were in flight, activities that were occurring in the on-prem dev and UAT environment. What we did was we drew a line in sand and said that by X date there would be a code freeze. And the code baseline from those environments would be migrated to AWS dev environment, and we would propagate upwards. After the code migration, we conducted a parallel production testing between on-prem and AWS by comparing the record count and making sure that each of the workloads was meeting SLAs. We determined upfront the data set to snapshot for parallel production runs. This meant that for some of our reporting requirements for those data sets, it may need up to 6 months, 12 months, and even further out. So what we did was once the code was migrated in AWS, pointing back to the source system, we start pulling data starting, for example, January 1st. And then any historical data prior to that, we will use Snowball to bring that data into S3. In fact, we use multiple Snowball edges and migrate over 350 terabytes of data. After the data was landed in S3, we established a lifecycle policy to move and archive data that was infrequently used to lower tier storage, such as S3IA and Glacier. After the data is migrated to S3, we shut down the on-prem workloads and repurpose the hardware for other projects. From a technology perspective, I mentioned we were moving off of Pivotal and Hawk. We use Snowball, Edge to move the data in S3. Besides EMR, we use Presto for interactive queries. Spark is used by our data science team to run their data science use models. Hive is used for the batch processing. And EC2 instances is used as our edge nodes. The Hive Metastore is used as a MySQL database. So what's our architecture design pattern? There are three. It's interactive and batch, real-time. Today, we don't have real-time use cases, but at least we want to make sure there's a framework in place should that day come. And data outputs and data consumer. Who and what application are connecting to your data? 100% we're doing this today. We're connecting to major source system. In fact, we're actually also connecting to legacy mainframe system. We're bringing vSAM data into S3. Based on how long our company has been around, it's no surprise that we actually have a very large mainframe footprint. So besides mainframe, we connect to various data sources across the board, the relational world. Those data sets range from transactional in nature and reporting. In some cases, where data sources requires large volumes, we use change data captured, and we use SyncSort as that mechanism to bring that data into S3. There are cases where we have to bring FTP data from third-party, such as third-party vendor from external sources. I mentioned about using the edge node to serve as a bridge between S3 and EMR. For data consumer, who are connecting to our cluster? There are data scientists, data analysts, business analysts, and there are business intelligence applications, such as Business Object and Tableau, and as well as other downstream applications. There are some use cases that require us to move data from S3 and into a data mart. Those options are MySQL, SQL Server, RDS, and NoSQL. We're actually rethinking this design pattern and going to be taking a hard look into using Redshift to support our data mart and data warehouse requirements. So how would we handle if we have real-time use cases and how we handle data stream? There are a couple of options. We could use Kinesis Firehose. We'll bring the data stream straight into S3. Or you can go open source and use Kafka. Also, Kinesis Stream handle the data stream and move the data into a couple of options for you to process those streams, which is Spark streaming, Storm, Flint. There's also cases where you need to expose your data through APIs. So Lambda is a great option, and also send notifications and alerts to your data consumers. Here are the benefits we saw in utilizing EMR and S3. It's highly cost-effective, as opposed to us managing ourselves at our own data center. Decoupling storage from compute is incredibly powerful. It allows us to scale at ease and at any time. Because insurance is in a highly regulated industry, we need to make sure that S3 and EMR satisfy all our security requirements. And it does for the most part. Automation has provided a great benefit for us. Allow us to spin up our edge nodes or additional cluster at ease and on demand, and also auto-scale based on increase in workload. We embrace open source technology, and we'd like to see the fact that EMR supports open source within their own technology stack. And lastly, having a highly resilient, highly scalable architecture is immensely powerful And for this reason, we feel that we're in position to grow our analytical capabilities and enable the business to drive actionable insights. Thank you very much.
We'll take any questions if you have. Yeah, we'll go here. The question is, what kind of challenges did you face when you migrated from Hive running on-prem to Hive on EMR and S3?
So a lot of our jobs that were on-prem, we were using SyncSort as our ETL. So in some cases, we didn't want to do a lift and shift. We had to refactor some of it. And a lot of time was the development effort that took to refactor those jobs, as well as a significant amount of time to regression test those workloads.
Yeah.
Yeah, so we don't have real-time use cases today, but those are options that we're actually thinking about leveraging. Most likely, Kinesis Firehose is probably the best option, but Kafka is also another option that we want to look into if we want to maintain and keep using open source.
Yeah. When you're moving from HDFS to S3, are you using DistCP to move data in and out?
We are. We were. Yep.
The S3 endpoint is, they say the S3 endpoint is public. Do you solve that problem, or do you use VPC endpoints?
We use VPC endpoints. Yeah. Yeah. So we use the edge node, which really acts as that bridge, and through IAM policy, it's the service calls are going through the edge node and then to S3. Yeah, so I mean, within our team, it was more easy because it's more of a decision that was more above me to make a company-wide decision to move into AWS. I think they did assessment on other cloud providers and just saw the massive benefits that AWS offered over everyone else.
If you look at the keynote that happened today, so Guardian's CIO actually spent a lot of time talking about that. And the gist was they actually did a gap analysis, and it took them almost a year to do the gap analysis between X and Y.
What if you don't want to take a year doing a gap analysis?
Well, yeah, then I think you tend to choose ones that quickly get your work done. I think that's what we've seen with a lot of people, that if you can get something done really quickly, that's where things will go. And it doesn't really have to be an org-wide decision. Just in case of them, it was an org-wide decision.
Yeah, we're getting an idea of a default provider, but not the only.
Sure. Still early days in cloud. Yeah.
Question on the financial model. So obviously when you're on premise, it tends to be a very big capital investment type, and that's one business case process. Are you now doing usage billing back to the kind of consuming departments? Is that part of the overall?
We haven't yet. Actually, we are looking into doing a chargeback model into other departments, but we haven't gotten to that. We're still in discussion. Yeah, because you got to look at different charge cost centers, the utilization. So it's a pretty complicated model to implement.
Who's the business side integrated with this architecture? Do you have an end-up layer and Arctic players, they have access to this, or do they access direct to EMR? How they are involved in the system?
Yeah, so we have a couple of business users. Some are the data science team. They have access to the edge node. And so we have two clusters. The ETL cluster, which no one have access from a business perspective, but also we have an analytics cluster. So our data science team can access the cluster in S3. Our business user, more of the business analysts, they access using different SQL tools and BI tools such as Tableau to connect straight into the Hive tables going through the Presto engine.
And therefore, the S3 is only one big bucket, everything is there, or it's
Right. Today, we have just one bucket. Yeah, and then everything's segregated and organized through a directory. In the beginning, we were using transient cluster, but because of we're actually shifting and looking and building up our Guardian Indian practice, so it required us to look into making the cluster long running. So we're actually using reserve instances to kind of manage the cost.
Yeah.
No, not yet.
Any reason? Because like this is a financial company, right? So is it like for your data consistency, it might not be very important. Or any you need to consider using EMRFS consistently.
So let me also clarify what EMRFS consistent view does. So EMRFS consistent view is useful when you have two parallel jobs, reading and writing data or updates to the data at the same time. S3 has read after write consistency for new objects. It doesn't have read after write consistency for existing objects. So if you have like a job that writes into S3 and at the same time there is another job that is picking up that data, that's where you start to use consistent view. For normal jobs that you're just reading and writing data to S3, you don't need consistent view to be enabled.
Because we actually faced some problem, like we wrote the data, and then even after 5 minutes, I'm not getting that object, right? So financial company, we found like this is a problem, right? Because the data is inconsistent. So we actually eventually went to EMRFS consistent view, and that created a lot of problems. What we can see, and then like S3 object not found, or the object is there in the metadata, like that's why I'm asking like whether you guys actually consider that.
Yeah, for us, we're using EMRFS.
EMRFS,
Yeah.
but with consistent view or without consistent?
I'm not positive which one. Yeah. Sorry.
Another question, do you guys still have Hive workload on S3? Like all move to Spark?
It was a question if we still have Hive. Yes, we still have Hive, and we're also using Spark as well. We're using both.
Same here.
So you had a question.
Yeah, I have a lower level question for your API. I noticed you were talking about using Airflow with some of your clusters, but not all of them. I was wondering what kind of workloads and such you're using to differentiate. How are you finding the Airflow integration? Or how are you, what kind of jobs do you better fit?
So if I understand your question correctly, you're asking what kind of job we run using Airflow?
Yeah, you seem to partition the jobs by Airflow versus just straight EMR or runner. I was just curious how you were partitioning. What are you using to decide your scheduling from Airflow?
We're not actually, that's actually not true. Maybe the picture is misleading or confusing somehow. So as we only use Airflow mainly as the scheduling service. So for example, one team, they have one EMR cluster. We basically, so one EMR cluster has a master ID, right? So in an Airflow job, we have operator basically provide the master ID, and the job will basically send it over to that EMR cluster. Sorry, what was that? Yes. You mean persistent cluster with EMR?
Because the workload is ad hoc, so anybody can submit jobs at any point of time.
And we're still in a process of evaluating and migrating the Hive, that part, the other workload over, the ad hoc piece. Right now, I think when we spin up a long-running cluster with about 20 nodes, just for a small team to use, it takes about 15 minutes. Yeah, we have some chef integration. That probably takes some time in there as well.
Have you used Ranger or on-premises AWS or
At the time, with using on-prem, we were using Ranger, but after when we moved to EMR, we didn't really have the time to implement Ranger. But I think they're coming out. Part of the roadmap is to implement some very features similar to that.
So the announcement that came out today around lake formation, one of the things that lake formation does is allows you to do fine-grained security on data that is sitting on S3. Ranger doesn't do S3. Ranger does only HDFS. You can still use Ranger with EMR if your data is only resident in HDFS. But the announcement that came out today morning about lake formation, which is our data lake story, is going to have integration for fine-grained resource-based control, and we're going to do it across EMR, Athena, Redshift, and Glue. So you'll be able to go to lake formation, you'll be able to say give X access to table Y, and that's how we will be able to implement it. It's not at all available right now. It's in preview. Yeah, question here. So, sorry, can you be a little louder if you don't mind? Yes. Correct. I don't know which talk you attended, but Athena doesn't. So I manage both Athena and EMR as a product. I lead those two products. Athena doesn't integrate with S3 Select today. So I think the reason for S3 Select is what happens is when you have, let's say you're running Spark on an EC2 instance where the data is sitting in S3. When you are running a query, the EC2 instance talks to S3 and pulls all the data into its memory because Spark is in memory and runs the filters, whatever you want to filter. Let's say if you have a where clause in the memory. What S3 Select allows you to do, it allows you to take the filter and pass it down all the way into storage. So I don't have to take the entire data set and filter in memory. I only take the result set in memory. So they're both using S3 as a data store. But in one case, I'm able to push the filter down to S3, and the other case, I'm processing the entire data set. So both are decoupling storage and compute in a way. One is being able to push down the filter, which S3 provides with S3 Select. Does that help? Okay. You don't look convinced, but I guess. All right. Oh, sorry, one more.
They do share the same meta store. So we have a gold and silver, right? Even if we migrated to split them into different small ones, we still have to pass the basically the endpoint of the either silver metastore or gold metastore to the EMR cluster when a job running, so that they can fetch the job, the partition correctly.
Any additional work on top of that to provide some consistency or locking mechanisms to prevent some unfortunate updates?
Not that we have seen so far. Basically, we haven't seen any issue with that so far. Yeah.
All right, thank you very much. Thank you for braving with us till 8 p.m. Appreciate it. Thank you.
Thank you.
Thank you, guys.